Simplifying by removing giant ones. This is a great technique, and it doesn't have to be eliminated to, or it doesn't just apply when you're looking at expressions. You could be looking at equations and you see kind of some messy terms, and it's probably a good idea to go through and try and simplify those terms as much as possible before proceeding. So if I look at this particular term, there's two things that immediately catch my eye. There are some common factors here, and I'm definitely going to want to rewrite them to fix that. So let's take a look at this problem. So the first thing I'm going to do is I'm going to use a giant one in kind of maybe an unexpected way. I'm going to multiply this by a y over a y. So it's not just a matter of removing the giant one, but I can use a new giant one to fix things. So if I take a look at this, my denominator now has a y to the first power times a y to the negative 1 power. Well, those two together equal just a factor of 1. They're just equal to 1. So by thinking about the giant 1 this way, it's kind of a convenient way of dealing with negative exponents. Because now all of a sudden I don't have a negative exponent in my denominator. What I have is 18x squared y all over 30, and then x to the fifth, and then just times the number 1. The other thing that I have here is clearly there's two factors of x in my numerator and denominator, and 18 and 30 both have common factors. 18 is 3 times 6, and 30 is 5 times 6. So I could rewrite this as 3 times 6 times x squared times a y in the numerator. And then in my denominator, I could write 5 times 6 times x squared times x to the third. So you'll notice what I've done is I've broke up the 5 factors of x I had into two groups, x squared times x to the third. It's still 5 factors of x in my denominator, but now I've got to a spot where I can very clearly see the giant 1, right? This is 6 times x squared over 6 times x squared. So that giant 1 can be completely eliminated from this expression. And when I do that, I get a numerator of 3y, and my denominator is 5 times x to the third power. So again, I used giant 1s here both to eliminate a negative exponent, but then also to significantly simplify the expression. You just look at the two of them and you're like so much happier with this one. Let's move on to our next example. So again, I'm thinking about a giant 1 here to simplify this expression. And I don't know that I'm going to use the giant 1 right away, but I'm definitely going to use it at the end, I think, to get rid of the negative exponents. But if I look at this, I'm multiplying two things, and I've definitely got a negative 5 times a negative 2. So I'm going to start with a 10. And then I've got x to the negative 2 and x to the negative third. When I multiply those, that's just going to be x to the first power. And then I've got a y times y to the negative 2 power, which would be y to the negative 1 power. So that's significantly simplified. The one thing that I object to is the negative exponent. So I'm going to multiply this by a y over y. I'm introducing this giant 1. Right? It doesn't have a value other than 1, right? I'm multiplying by the number 1. So I don't change the value of the expression, obviously, because of the multiplicative identity. Anything times 1 is itself. So when I look at this, my numerator it's now 10 times x to the first, and then y to the negative first, and then y to the first. Y to the negative first times y to the first is just 1. So my numerator is now 10x, and my denominator ends up just being y. So this is simplified, vastly simplified expression compared to the original one. And at the end there, I did use a giant 1 to eliminate the negative exponent.